Hello everyone. Welcome you all in the session of estimation of manhole. Myself, Faiz Arshad Sudarji, Assistant Professor, Government Engineering College, Karwar. So today we'll study how to estimate the manhole. So before that, we should know the definition of manhole and where it is provided in the entire drainage system. So first definition of the manhole, or we can call it as sometimes it is inspection chamber, is a unit constructed underground to provide access to the utilities like sewer systems, drainage system, etc. Hence, with the help of a manhole, underground utilities are inspected, modified, cleaned and maintained. Now from the below sketches we can identify the function of the manholes. So it is underground structure. You can see how the drainage pipes are connected to the manholes and how the manholes will be constructed from the sketch shown in screen. Next, purpose of manhole. The main purpose of a manhole is to perform inspection, cleaning, removal of any obstruction present in the sewerage system. Next, the joining of sewer, the change of direction or the alignment of sewer can be performed with the help of a manhole. These have a perforated cover which helps the fall gases to escape. Hence, it is good means of ventilation for the underground sewerage system. Manhole helps to lay the sewer line in conventional length. These are the features of manhole. So in the sketch we can see the different parts of the manhole. So moving from the top, top will find a manhole cover which has perforation so that gases can be evaporated. Okay, so ventilation of the sewer can takes place. Second, that is fitted to the manhole ring. Then a small portion below the manhole cover is called a chimney. Then it is enlarged and connected to barrel section. So enlarged section is called as a cone section, and we have barrel section next to the cone section, and there are steps, steel steps will be provided, small rings that will act as a ladders just to go down and up. Then at the bottom a benching will be done. Then sewers will be connected to that one, and sewers are sloped. One side its elevation is high and one side it is less, and bottom will find a bed or something hard bending will be done to fix the sewers. So these are the some of the basic points which we have studied earlier in environmental engineering 2. Now come to our main topic, that is estimation of manholes. So I'll read one example and we'll see the sketch of which manhole that we have to estimate. So first prepare a detailed estimate of a manhole from a given drawings. Foundation and floor concrete shall be of 136 with brick ballast. Brickwork shall be of first class in 1:4 cement mortar. Face of wall shall be pointed with 1:2 cement mortar. Then inside channels and benching floor shall be finished with 20 mm thick plastering with 1:3 cement mortar. So 1:3, 1:2, 1:4 means already we know it is one part of cement and 2 part of fine aggregate, or 3 part of fine aggregate. Yes, we will see the sketch of the manhole. Yes, so manhole sketch has first top sectional elevation, then bottom plan and its cross section. So first we will see the sectional elevation on section AB. So AB means it is section in the plan. So AB where section is cut in the plan. Now we will see the section sectional elevation on AB. Yes, so from road level you can see the 45 centimeter dia CI manhole cover that is fixed to 100 mm RC slab. Then a small entrance shaft is there which has a clear width of 600 mm and it depth below the slab RC 100 mm RC slab is 700 mm. Then we will find after entrance shaft there is a working shaft. So that has a width of 1.8 meter, and we can see the walls of this chamber. Top has top wall thickness has 200 mm, next step 300 mm, and last step is 400 mm thick. And we will find one after entrance shaft again we have provided 120 mm RC slab over working shaft, and bottom we can find the 40 centimeter dia SW main sewer pipe, and in the section also we can see a branch line is joined to the main sewer. Then bottom all those are that 40 centimeter dia main sewer pipe is provided on 20 mm bed concrete. So we have to estimate this. So hope we got all the details. Next come to the plan. That plan we can see first the out to out dimension, that is the bed concrete, and out to out dimension is 2.8 meter into 1.9 meter, and we can see main line along AB, main sewer line, and a branch line of 20 centimeter dia is joined, and dotted line we can see the entrance of the manhole, and we can find the circular 450 mm cover also we can see, and we can see the steel ladders. And in this plan sections are done along AB and EF. So AB is sectional elevation we have seen. Now come to sectional elevation along EF. So here we can see the walls which has different thickness like 200, 300, 400. Then we can see the iron footsteps here in a staggered position, and different depth of the walls also we can see, like 700 mm, the next 1000, then 900. That whole arrangement is fixed on the 200 mm bed concrete, and a sewer is fixed by benching of the concrete. Now we can see this. As top we can see the 100 mm RC slab and 45 centimeter dia CI manhole cover. Now this is what the sketch of the manhole, where plan is there, then section along AB is there, and section along EF is also there. So before estimating or wherever you are attending listening this class, so my suggestion, you take printout of this drawing sheet and attend this class. Okay, so come to next one. So we'll start the estimation of a manhole. So first item, yes, of course it is excavation, that is earthwork in excavation. Now from the sketch we can see some sketches for reference we have added in the slides. Now we can see, if you refer sectional elevation on EF, how much depth we are excavating. So first item is earthwork in excavation. So number means for 0 1 only, so 1 for each manhole, number is 1, and length we can find from the sectional elevation on AB. So maximum length is 2.8 meter, that is the length of the concrete bed block. Then width, breadth and or width as 1.9 meter, that we can found from the sectional elevation of EF. So that is the maximum width, 1.9 meter, and depth we can find in this section only. So just add the all the thickness of the steps, like just move from the top 100 mm RC slab. So next 700 mm thickness of first step, depth of first step, then next step 1 meter, then next step 900 mm, at last thickness of the concrete bed as 200 mm. So if you add, you will get a total 2.9 meter. So in explanation also we have to write how we got the total depth. So H is equal to that we have provided in terms of centimeters. So 10 centimeter thickness of slab, then 70 centimeter first step, then 100 centimeter second, then 90 centimeter third, and last 20 centimeter. So if we add, you will get 290 centimeter, means 2.9 meter. So I will repeat this once again. Total number 1, then length 2.8 meter, and breadth 1.9 meter, and height or depth is 2.9 meter. So you can calculate its quantity as 15.43 meter cube. So this much of excavation, quantity of excavation. So these dimensions you have to refer these sketches. For examination, you no need to draw these sketches, just for your reference we have added some detailed sketches here. So in examination you have to write only the values by referring the sketches. Okay. Now come to second item, and we have provided some sketches just in explanatory note, just for your reference. So second, after excavation, second item is cement concrete with brick ballast. So here two item in that two places we have done cement concrete with brick ballast. One is foundation, and next one is at bed benching. So at side in explanatory note you can see the sketches just for your reference. So starts from first one, benches, foundation. So foundation bed concrete, we know the sketch in elevation, section and plan. So one quantity is 1, number is 1. Its length already we have seen in previous slide, its length is 2.8 meter. Then its breadth 1.9 meter, and thickness is 20 centimeter or 0.2 meter. So we get quantity of 1.06 meter cube. Next, for bed benching, so if you see the color of benching, it's moving, it's tapering towards the center line of the pipe, means whatever falls over that one should flow to the pipe. So there is a sloping will be done, okay, in two sides. So for that we will do this some deduction work later on. So first we will calculate as a whole, as a square only, okay. So you can see its length from the plan, length of the benching 1.8 meter, and you can see from section its width is 0.9 meter, and will consider height or depth complete as 400 mm, is complete its diameter, till diameter it is finished, it is filled. Then tapering part will be deducted later on, and deduction is done for one branch line will be joined to the main sewer. So that also we will calculate in deduction part. So foundation, cement concrete with brick ballast in foundation 1.06, then for a bed benching it is 0.65. So total we got as 1.71. in that we have to deduct. So first upper portion of the main channel we will deduct. Now we can see it's number one only, and the length as it is same length of the wall, that that is 1.8 meter, and the width we have to calculate. So we will calculate at its look like a tapered portion, trapezoidal, okay. So it is cut exactly at center point of the pipe, means that sewer is cut 50%, okay, and benching is tapered. So the total width of the tank is 900 mm, and it is joined at mid portion, center of the sewer, means if you calculate its width, so width of means diameter, we can take diameter of the pipe. So inside diameter is 0.38, okay. So outside diameter is 0.4 meter, and inside diameter of the pipe is 0.38. So inside point will join, okay. So now we will take the average width, okay. So top width is 900 total, then till its minimum width where benching will be done, that is 0.38. So if you take average of that one, 0.9 plus 0.38 divided by 2, and its thickness of benching. So here it is 0.15 meter is the depth or thickness of the benching. So where we have to deduct. So we get a quantity 1.8 into average width, that is 0.9 plus 0.38 divided by 2 into its height 0.15. So we will get 0.17 of quantity we have to deduct. Next one branch line is joining. So that length is 0.3 meter, and its diameter is 0.2. So we will consider it as square only. So 200 diameter means we will consider as 200 into 200 cutting. So and its height is 0.15 meter, means that much of depth that benching is cut in, means that much cutting will be done for to provide the branch sewer. So total quantity is number 1, its length is 0.3. This 0.3 is perpendicular to the, this length 0.3 is perpendicular to the axis of the main sewer, okay. Now we can see a shaded portion is shown just beside the sketch in explanatory note, that length 300 mm, 0.3, and its width 0.2 means diameter will have consider as a square only, okay. And its height or depth, that is 0.15. So this we can refer in sketch, okay. One reference is there, you can refer. So we got this quantity as 0.01. So total quantity we have to deduct is 0.17 plus 0.01. So divided by so total is 0.18. So that we have to deduct from the total quantity of cement concrete with brick ballast, that is 1.71. So we get net total quantity as 1.53. So in explanatory note it's given 1.7 minus 0.18, that is 1.53. So this much quantity of cement concrete with brick ballast will be done. This quantity is in terms of meter cube. So first quantity is also in meter cube, second quantity is also in meter cube. Now come to third item, that is brick work. So again section is given, section and plan is given, just to easily understand the which dimensions are taken. Okay, so even in sketch also you can find. Okay, these are just for your reference. So this item is first class brick work in 1:4 cement mortar. So here deduction of pipe should not be done. So now we will calculate the quantities using long wall and short wall methods. So first one we will consider the long walls. So first we will consider long wall of first step. So two numbers are there. So here in section also you can see two numbers, and its length 2.6 meter, then breadth 0.4 meter bottom wall, and its height is 0.9 meter. Then total is 1.88. Second step of the long wall, again two numbers, and its length 2.4 meter, and its thickness 0.3 meter, and height 1 meter. And last wall step, two numbers, but here length is 1 meter, because it is the entrance of the entrance wall of the manhole. So you can see from the plan and section also its length is 1 meter, and its width thickness is 0.2 meter, and height is 0.7 meter. So you will get 0.28. In explanatory note you have to write how you got that length of the wall, as 0.6 meter is the opening, then 0.2 meter thickness either side. If you add, you will get a total outward length is 1 meter. Then come to short walls. First again step from bottom, two numbers, its now length is same only, because you can see from the plan how we have considered the outward of the long walls. So remain only is the 9 meter length. So all short wall length are 900 mm only. So to first step 900, second step 900, third step also 900, uniform width. But here breadth are in changing. So bottom is 0.4, next step 0.3, and last step 0.2, and its depth are same 0.9, 1 meter, and 0.7. So quantities are listed in quantity. So total quantity of first class brick work in 1:4 cm is 5.04 meter cube. Now come to fourth item, that is cement pointing in 1:2 cement mortar. Here mix is very rich. So here dimension, this quantity is measured in terms of meter square. So we can see how much area we can calculate very easily from sections. Okay, so sections of the wall. So for your reference, one section of the wall is provided below. Now come to that one, cement pointing in 1:2 cement mortar. So long wall up to slab, that is two numbers, its width is 1.8 meter, and height is 1.5 meter. So you can see in the sketch the dimensions of the wall. Then short walls up to slab, so two, into same 0.9 meter. So this dimension you will get in section of the wall. So again height is same 1.5 meter only. So we will get quantity in terms of meter square. First one 5.4 and second is 2.7. Then remaining short walls. So short wall left side one number 0.9 meter and its height is 0.82 meter. So you can see how 0.82 meter is calculated, that is 700 mm plus thickness of the slab 120 mm. So if you add you will get 820 mm or 0.82 meter. Then short wall right face 1.9 and it is 0.7 only. So 0.7 means thickness of this slab is not included here, and you got a quantity of 0.63. Then above slab remaining faces 2, its width is 0.6 and its thickness 0.82. So this is nothing but a surface, complete surface area of the walls. So we got a total quantity as a 10.45 meter square. Now come to the next item, that is 20 mm thick cement plaster in 1 in 3 cm in floor and channels. So number 1, so length we know 1.8 meter. Now breadth we will consider 1.2 meter. Total we have calculated. So quantity we got 2.16. So how we got this 1.2 meter means width is 0.9 meter of the channel plus 0.3 we have added extra, means 0.15 plus 0.15. Okay. So additional 30 centimeter, that will to take care of a curvature. So 1.2 meter is the width and its length 1.8 meter. So this much is the quantity of 20 mm cement plaster. Now come to next part, next item, that is RCC slab including steel complete work. So in first one in roof slab of the working chamber. So number 1 is there, length is 1.35 and its breadth is 1.2 meter and thickness of the slab is 0.12 meter. So total quantity we got as 0.194. Next shaft roof slab of the so that is roof slab of a shaft, that is 1, length 0.8 meter and its breadth 1.1 meter and height or thickness of the slab as 0.1 meter. So we got quantity 0.088. So total quantity of RCC slab is 0.282. In that we have to deduct the manhole cover. So we know the size of the manhole cover as 45 centimeter. So deduction is that area of the manhole cover, means pi by 4 into 0.45 square. So 0.1 is the thickness of the slab. So total quantity of deduction is 0.016 and net quantity of RCC slab is 0.266 meter cube. Next item is CI manhole cover, 42 centimeter diameter including a frame, that is quantities in terms of a number only. So one number is there, so quantity is one number only. Then iron foot step, 7 numbers are provided. So we will take 7 numbers of iron foot step. Next item is 16 mm dia bar. So these are the total 8 items. So at last we have to prepare the abstract of the estimate. So we have prepared, but we have not added here rate. So rate whatever rates, latest rate, current rates for each quantity has to be taken and net amount should be calculated. So this is the abstract of estimate. So here all items are mentioned, like earthwork in excavation including timbering as required. So total quantity we have calculated, net quantity as 15.43, unit is meter cube. Then second item, cement concrete with brick ballast, quantity is 1.53, that is also in meter cube. Then next, first class brickwork in 1 in 4 cm, again its quantity is 5.04 meter cube. Like that, for cement pointing, then plastering in channel, and RCC slab, next manhole cover, and iron footstep of 16 mm diameter. So these are the total 8 items, and its quantity will be calculated and its amount. So at last we have to add 3% as contingencies and 2% for work charge establishment. So we will get a total grand total amount required for this estimate. So this is what about the sample estimate of the manhole. So like that we have to estimate different types of manholes. Okay, with this I will conclude this session. So we will see next session different estimates. Thank you everyone.